Hello and welcome everyone. Today we're going to be discussing the UK Bebras Coding Challenge. Well, first, what is the UK Bebras Coding Challenge? This is an event for UK students aged 10 to 19 who took part in this year's UK Bebras Challenge. Formerly, this was known as the OUCC, and this was the next step for the UK Bebras participants, but now they have called it the Bebras Coding Challenge. This will run between the 24th of March and the 4th of April this year. And the aim of this 45-minute coding challenge is to enhance skills, build confidence, and inspire students to develop program solutions to computational thinking problems. In this video, we're going to be looking through some questions from the Explorer Challenge group. All of these questions are available on the Bebras website. I'll show you how to access them and how to access some more useful information on this website. All right, so over here we have the home page of the UK Bebras website. To go to the coding challenge section, you find the tab at the top, and the Explorer challenge is among the block-based challenges. So this requires no knowledge of any text-based programming language. You'll find all the information you need about the challenge over here. We're going to be looking through the Explorers challenge. So all the useful information will be over here. So it's a 45-minute challenge. It's made up of 10 questions in total. The first 8 have 4 marks each, and the last 2 have double that at 8 marks each, as they tend to be more difficult than the first 8. We have a summary of the math skills required, the programming constructs we are required to know, some other math operators, relational operators, as well as logical operators, what you need to know about string handling, data types. Now, in particular, these links are quite beneficial and helpful when you're looking through the website. This PDF contains a summary of the blocks that are required and describes what each one does and how it can be used. You can find some tutorials that discuss the different parts or the different types of questions that you might encounter in the challenge, and some video guides that go through the different categories of blocks that you can use. Now, finally, to get to the challenge that we're going to be going through, we go to this practice questions segment of the page. We have the challenges page, and we've got a whole set of coding challenge specimen papers. And today, as we said, we're going to be going through the Explorers challenge. We've got the set of 10 questions here. As discussed before, we've got the first 8 have a difficulty of A, and they're marked at 4 marks each, whereas the last 2 questions have 8 marks assigned to each one, and they are more difficult than those first 8 questions. So we're going to start with the first question, heart. Now, one very important and very useful tip is this one here. For more programming space, you can use the hide menu button over here. So you hide the menu that shows the list of all questions, and this just gives us more space to put our blocks and know what we're doing in the programming side. We can zoom in and out on our programming space. You can click and hold to scroll around or use the scroll bars. Then over here, you can run the existing code. Now, typically this would be done in a way where it goes from the topmost block to the bottommost, and that's why it's running this block first. Whereas, if we put this at the top and we run, this is the first thing it runs. You can do it step by step by just clicking through on this button. You can clear the workspace to get rid of all these blocks. You can reset to go to the very beginning of the execution and have it do it again. And over here we have a slider that controls the speed at which the program is executed. So if we put it at the fastest and we run, you can see kind of what is happening over here. Now, in this question, the blocks are already all there, and all we need to do is rearrange them so that we get this heart shape. So Aaron is distraught. There are no more blocks left, and those I used to make my heart shape have all been moved around. And what we have to do is rearrange them to rebuild Aaron's program. The program should exactly draw the heart shape shown faintly below. Now, the first thing we notice here is that the drawing doesn't actually start from where the pen starts. So we're going to have to start by lifting the pen up and repositioning the pen to a place where we can start drawing before we can then put the pen down. So we might try to move up here to start the drawing from here. But all the move forward blocks we have values that are way too big. So if we try and move forward by 130 and we just run, you can immediately see that this is way too far from where we want to start. So moving forward will not be our first move. Instead, let's try moving back and see whether this places us in the right position. Now I'm going to set the speed to very slow so that we can carefully see every single move as it happens. And we can see here that it has moved back by 100 steps, and now it is exactly where we want it to be to start drawing the heart. Now we're going to need to turn either right or left by some angle that's less than 90 degrees to start drawing the heart shape. So we look through our blocks. This is a turn right of 180 degrees, which would cause it to turn all the way around the other side. These are repeated blocks that we're going to use to draw the curves of the heart, because what's happening in each one is we're moving forward by 2 and turning left by 2, repeating this 113 and 114 times. So we're going to try the turn right by 47 degrees and see if this is what we want. And in fact, you can see that it's turned right and it's ready to start drawing. Well, to start drawing, we need to make sure we put the pen down so it starts drawing. And the first part of it is going to be a straight line before we then start doing the curve. So it has to be one of these move forward 130 steps blocks. Now, after we've moved 130 steps, we're going to need to start curving and turning to the left slowly until we get to this point. So it has to be one of these two blocks. The only difference between them is this one repetition. So let's try doing the repeat 113 times. So if we go next step, this is going to be useful up until this point, but then we're going to have to keep clicking next step for each repetition. So at this point, it might be useful to speed up the execution and run. See if this is the right curve that we want. And it seems like it's following the path that we need it to follow. And it's gotten all the way to the upper center. And we want it to stop there. Now, what we could do actually at this step is we could disable these blocks just so they don't get executed. And we check what happens when we run only these blocks. Now it's stopped over here. And what we want it to do is turn around and do the rest of the curve. So remember, we already discussed this block. We're going to enable it again. Make sure we're not deleting because these are the blocks that we need for the program to run. We're just disabling it so it doesn't run. After it's turned around, we're going to need it to start doing the same curve. So we're going to try this repetition over here. And then we're going to finish it with moving forward to create that last curve. So let's try that. Now you can see here, let me just show you again, and we'll pause it there. This does not follow the path exactly. So it's slightly off this track that we need. And you can check at the top, it says incorrect. So let's try swapping these two repetition blocks, doing the 114 first, then turning around, repeating 113 times before we do the straight edge. And if we do that, you can see that now it aligns perfectly with the shadow that was there before, and at the top it gives us this green bar which says correct. And we can then move on to the next question. First thing we're going to do every time is just hide the menu to make sure that we have more programming space. And if we want to check our progress, we can always open up the menu again, have a look at the list of questions, and refer back to that. Now, for the second question, Hilbert Hiccup. Hilbert's curve is a famous fractal design. Like most fractal programs, the code is recursive. This means it contains a function that calls itself while running. The function in this program calls itself several times. The program given below has a single numerical error in it. And our task is to debug and fix the code to draw the required pattern. It's always useful to have a read through the information given here. Sometimes it's some useful tips, other times it's some numerical values that are quite useful when you're doing your program, and we'll have a look at those in the upcoming questions. So here it says you can run the provided code to see what actually happens. It is a good idea to slide the speed to hair when you need to submit your answer, but this will be far too fast for debugging. The answer will not be submitted until it has finished running. So when we're debugging and trying to find the error, what we're going to do is slow this down and have a look at what goes wrong. So it seems like it's starting in the correct place. And then as it moves, we're going to monitor and see if it's going through the correct turns and covering the correct distances. And over here, I can already spot that it has not finished this whole length. So it made this turn correctly. Even here, it made the correct turn, but it did not cover the correct distance. So let's go back and do this step by step to see where exactly it goes wrong. So as we go through it step by step, we can see highlighted over here the part of the code that is being executed at that time. So currently it's checking if level is not equal to 0, it's going to do the following. So it's turning right by that angle, and then it's calling the recursive function again. And we're going to keep clicking until we get to the point where the error is made. So here is all correct. It turns and then it moves forward by 15. And we can see that this did not cover the full distance required. So in the previous turns, it had moved forward 25, but in this one, it moved forward 15, and this was not enough to get it to the end. If we go to the next step, it does something similar here where it moves forward by 25, turns left, and moves another 25 until it gets it to the end. So this block seems like it's correct so far. Let's try changing this to match the other values. So let's try making it 25 and see what happens as we run our program. Let's maybe speed it up. And hopefully it will now at least make it to the end of this path. And it seems like it's going along the correct path with this change. We can speed it up to check if it makes any other errors, but it seems like it's set. And if we speed it up to the hair, and our final confirmation will be by scrolling up and checking that we get the correct banner at the top. So in this program, as well as the last one, we weren't meant to change any of the blocks or add any new ones. For the previous question, all we had to do was reorganize them in a way where it created the heart shape. In this one, it was just a single numerical error in it. So we need to make sure we read the question very carefully before we start answering and adding some blocks. All right, so we're going to move on to the next question. We're going to hide the menu. And here we have another heart question. So a heart shape can be constructed with a square and two circles. The heart shape, shown faintly below, can be constructed with the shapes drawn by these three blocks. So we draw a square with 100, draw a circle, 71, and another circle, 71. You will also need to use the set position block. Write a program that uses these blocks that exactly draws the heart shape shown faintly below. So let's start by just creating these three blocks because we know for a fact we're going to need them. So a square with a parameter of 100. Then we're going to use the same block, and over here you can click on this menu and you get all the different shapes that you can draw. So we're going to choose a circle, parameter 71, and a nice trick to save us some time is to right click on a block and click duplicate. And this creates an exact replica with the same values, same shape, and same value over here of that block. So let's see what each one does. So if I start by just creating that square, well, I can see that something is not quite right. And same thing when we draw the circle. Well, let's start with the square. I have a right angle at the bottom of this heart here, which tells me that actually when I draw my square, it needs to be tilted. So it's going to occupy kind of this space over here. So what I'm going to need to do is turn in a certain direction to draw this square. Well, if I turn right by 90 degrees, if you think about it, if you rotate a square by 90 degrees, it keeps the same shape. So I'm going to need something exactly in the middle. So something like 45. And now when it turns to 45 and it creates the square, I can see that now it's filled up most of the heart, and we can identify where we're going to need those circles. So I'm going to need one circle here and the other circle here. But of course, if we start drawing the circles, these are just going to be drawn in that same position under the square. What we need to do is change the position of the pen before we draw those circles. Well, let's look at the center of each circle. Now, the nice thing about these grids we get in the coding challenge are these indicators of the x and y coordinates. The x coordinate runs horizontally and it goes from 0 all the way up to 400. And then we have our y-axis, which runs from top to bottom, as opposed to what you might see in a maths class. Here we have 0 at the very top, going down to 400. So let's think about this circle on the left. Well, the center is going to be around here, halfway along this side of the square. So the x-coordinate, if I trace it up to C, that's going to be 150. So before we draw the circle, let's set the x position to 150. So it's exactly in the middle between 100 and 200. The y-coordinate, well, that's also down the middle between 100 and 200. So that's also going to be 150. And let's just check that we've got the right position. So we turn, put the square, then we move the position and we can see that it's kind of in the center of the circle. So when we draw the circle, it's filled up this part of the heart. And now we just need to do the same thing on the other side. So let's think about the center of this circle. Well, it's along the same y-coordinate. They're on the same level vertically. But horizontally, well, this one is more shifted to the right. Its x-coordinate is going to be between 200 and 300. So that's 250. And as we said, the y-coordinate is going to be 150. We're going to need to set the position again. We said x-coordinate is going to be 250. Y-coordinate is going to be 150. And then we're going to draw our circle. And we can do this step by step, or we can increase the speed and check that this gets us the correct answer. And in fact, it does. Remember to always check that we've got this banner. Now, this only shows when you're doing practice challenges. When you're doing the actual challenge, this doesn't necessarily show up. Right. So we're done with the red heart question, and we can now move on to the next one. Is it a robot? This is a movie-based question. So I'm going to start by hiding the menu. Now, it says press run to see how the robot moves. So we can pause this execution and we have a slider that allows us to go through time, which goes from 0 all the way to 100, and examine at each of these individual time intervals what exactly is happening. Again, it's very useful to read through the information so that we know exactly how to approach this problem. The colors shown are faded version of the true colors. The pentagon is purple, So this is middle right in the color picker, and we'll have a look at what that means. The line that forms the leg is black, and that's bottom right in the color picker. The line thickness and the number of sides are both 5. All other variable values are multiples of 10. This is what I was referring to earlier about them indicating in the information what values we should use. So we have a new tab here, which is the movie tab. And this includes the time block. Now we're going to get to this in a second, but before that, let's have a look at the shapes. So let's try running this shape over here. This has created a red circle in this position. So if we have a look here, we have the number of sides, and the way it works for this shape is if we put 10 sides, it creates a circle. Well, they told us here that the number of sides we need for the pentagon are 5. The color we need for the pentagon is purple. So we click through here, and they've even indicated where this lies in the color picker. It's middle right, so it's this one over here. So let's try that. Now we have the correct shape, the purple pentagon. But we need to make sure that this is placed in the correct position. So we're going to do what we did in the previous question, and we're going to look at the center of the pentagon. So the x-coordinate of the center, if we look up at these indicators, is 20. So it's actually in the correct x position. The y position is 40. So we're going to need to adjust that so that it becomes 40. Now if we run, the pentagon is in the correct starting position. But what happens if we keep going through the time using our slider is at time equals 40, you see that the pentagon starts moving to the right. And this keeps happening until time equals 80, and then it stays in place. So we'll worry about the leg of the robot later. Let's just think about the pentagon itself now. It starts in this position. It moves as time goes along, and then it stops. So this is where we could use this time block. This takes value exactly equal to the time indicated here. So for example, if I put that the x position is equal to time, this means at time 0, the x-coordinate will be 0. And as time increases, this x position will increase. So when time is 40, it's going to be 40. When time is 50, x is going to be 50. And it moves according to this time. But what we want to do is actually have it stationary, have it stopped in its position up until time is 40, and then it starts moving, and then have it stop again at 80. So we're going to have a think about that. But before we do that, let's also think about our line. Let's just disable this block for now so we can clearly see the line. So we have the Shape tab to create shapes like pentagons, circles, squares. Then we have the Line tab. Now, here It looks similar to the shape in that you can create a certain name for it. So we can call this the pentagon, and we can call this the line. It's similar in that it has a color picker as well. They said the line that forms the leg is black, and that's bottom right. So it's this one over here. The line thickness, just like the number of sides, is 5. So we're going to change the thickness to 5. And let's just have a look at where this line is right now. So it's starting at 0, 0, so over here in the corner, and it's going all the way to 20, 20, this point over here. So for a line, we choose its thickness, where it starts, and where it ends. Well, let's try setting it to this position. It starts at 20, and the Y position at the start is 50. And where does the line end? Well, it goes all the way over here. So the X position is 0, and the Y position of the end is 90. So we run that, and in fact, it is in the correct place now. But the line moves immediately from the start, and it actually changes position quite a few times. Now, what we notice is from time 0 until time 40, it's just the end position of the line that changes. It's still starting from the same place, but the end position is changing from 0, 90 to 40, 90. Then between time 40 and 80, it's the start position of the line that changes. And then after time 80, we have the end position of the line changing again. All right, so how do we deal with these changes in position using the time? Well, the easiest way to do this, since we have two shapes that are changing positions at different points of the program, is we could go into the Logic tab and we could start an if statement. What this does is it checks some condition. If something happens, then do a certain thing. So we're going to start by saying if, well, what did we say? The first changes are going to happen between time 0 and time 40. So we're going to use this logic block, which allows us to do equality as well as inequalities. And in here, we can say less than or equal to, and we can use the time block that we talked about. Right? So we could do if the time is less than or equal to, well, the first block, as we said, is going to be all the way up until 40. So if the time is less than or equal to, we need to put a 40 here. All numbers and mathematical operations can be found in the Maths tab. We're going to grab this block, put it over here, and we can change the number to 40. So we're saying if the time is less than or equal to 40, so from 0 to 40, do the following things that we're going to put in here. Well, we're going to add a pentagon that is in this position, and it's not going to change position in these first 40 seconds. Then we add the line, which does change position in these 40 seconds, or 40 time intervals. So, as we spoke about before, the start position of the line does not change. It's the end position that changes. Well, the y position of the endpoint does not change. It starts at 90 and it finishes at 90. So we're going to keep this as it is. And of course, as we said, the start position will remain unchanged. But it's this value that we need to change. At time 0, the x-coordinate of the endpoint is 0. And it changes exactly with time. So when time is 10, the x-coordinate of the endpoint is 10. When time is 20, the x-coordinate of the endpoint is also 20. And this keeps happening until it gets to 40. So here also we have when time is equal to 40, the x-coordinate of the endpoint is 40. So actually, the x-coordinate of the endpoint is equal to the time value. So we're going to use this time block again and set it as the x-coordinate of the end position. And now you can see that the leg moves correctly as time goes along. And this is all the way up until the time is 40. Then, the next block we have to worry about is this time interval between 40 and 80. Because after 80, it's a different movement. So we're going to leave that as a separate block. We're just going to do 40 until 80. Now, we can see on this if block something that we haven't seen in a block before. And it's this blue icon with a cogwheel on it. This allows us to change certain things about the block. This currently says, if this condition is true, do the following. So if time is less than or equal to 40, add the pentagon in this position over here, and add the line with this starting position and an ending position where the x-coordinate follows the time exactly. Well, we can add two different things. The first thing we're going to add is an else-if statement. This means check the condition at the if first. So if time is less than or equal to 40. So when this condition is true, it's going to run these blocks. When this condition is false, so time is not less than or equal to 40, it's going to go and check another condition. And in here, we're going to do something similar. Remember, we can right-click and duplicate, and that saves us some time when we're completing the challenge. And what I'm going to do is say time is less than or equal to 80. Now it's important to understand why we can do this without worrying about whether what we put here will be executed even between time 0 and 40. Because technically, 0 to 40 is less than or equal to 80. But it always checks this condition first. And the only way it gets to this point to check this condition is if this one is false. So if time is greater than 40. So this is saying if time is greater than 40 and it's less than or equal to 80, do the following. And this is quite useful for us because this is exactly what we need here. We want something to apply between time 40 and 80. And what we're going to do is, in this time frame, we also want to add the same shapes. We have the pentagon and we have the line, but we're going to need to change around their positions. So I'm going to duplicate each one. Let's do the pentagon first. Now, the pentagon, we've put it at this position, so at its starting position, but we actually want it to change its position as time goes along between 40 and 80. So let's think about what's changing in its position. Once again, the y-coordinate, so where it lies vertically in the canvas, is unchanged. It's not moving up or down, it's moving to the right. So the x-coordinate is changing. The x-coordinate is changing from 20 at time 40 to 60 at time 80. And here we're going to have to use some maths to think about how this x position corresponds to the time. Let's think about it again. When time equals 40, the x-coordinate is 20. So if we think about it, the difference between the x-coordinate and the time is 40 minus 20, which is 20. So this is 20 less than the time. Let's check what happens at time 60. When time equals 60, the x-coordinate is 40. So once again, the x-coordinate is 20 less than the time, right? There's a difference of 20 between the x-coordinate and the time. And it keeps going all the way up until time becomes 80 and the x-coordinate is 60. Once again, we see that there is this difference of 20 between the x-coordinate and the time. So we're going to keep the y-coordinate unchanged, but the x-coordinate is always 20 less than the time. So we're going to need to use a maths block. And in here, we're going to do a minus. We're going to say it's time, take away 20 to get the x-coordinate. So let's check that this does the correct thing. It stays fixed for the first 40 seconds. Then it starts moving as the time goes on, all the way up until it's 80. And notice that after 80, we still haven't said what's going to happen. So the shape disappears. So before we get to that final phase of the question, we still need to think about the line. I'm going to disable this again, just so we can clearly see the line. Because between time 40 and time 80, it's the starting position of the line that's changing. Whereas before, it was the end point of the line that was changing. So in the first 40 values of time, the endpoint was changing. Then that stays in place where the x-coordinate is 40, the y-coordinate is 90. The endpoint stays in place, and it's the starting point that starts moving. Well, we're going to duplicate this again because we need the same line, as in the same color, the same thickness, but we need to rethink the start and end position. Let's start with the one that stays fixed, the end point. We said this is x-coordinate 40 and y-coordinate 90. So the end point does not move. We just need to change the start point of the line. Well, once again, we see as the line is moving, the start point doesn't move up or down. So actually the y-coordinate is unchanged. It's just moving to the right. So it's the x-coordinate that is changing. And it goes from 20 all the way to 60. Let's check that again. At time equals 40, the start point has x-coordinate 20. Do you see the pattern? Again, the x-coordinate is 20 less than the time. And you can see actually it moves at exactly the same speed as the pentagon. So it's moving just like the pentagon. And at the end, we have an x-coordinate which is 60, also 20 less than the time. So we can use exactly this same formula, which is time minus 20 to determine the start position or the x-coordinate of the start position of the line. And let's just enable this to make sure we've got the right thing so far. So from time equals 0 to time equals 40, we have the end point of the line changing. Then the end point gets fixed, so it's not changing. And now it's the pentagon, or rather the x-coordinate of the pentagon and the x-coordinate of the starting position of the line that are changing. They're shifting to the right, and they're always 20 less than the time. And then we get to the final phase, which is what happens after time equals 80. And once again, we're going to have to revisit this blue cog and say, now we're going to add an else statement. This is slightly different to the else if. So Else means get here if the previous condition was false. And if checks a condition. So this kind of does both. It's saying if this is false and this is true, do the following. So if time is greater than 40 and less than or equal to 80, do the following. Else has no condition. Else just means if all the conditions that we have checked are false, do what's inside here. So if time is not less than or equal to 40, and it's not less than or equal to 80, which means if time is greater than 80, which is this segment that we want. Well, once again, just like the first segment, here, the pentagon is not moving. The start position of the line is not moving. So let's start with those because those are easier to program. We're going to duplicate this pentagon, and we don't have anything changing, so we're not going to need any mathematical blocks or the time block in here. We just need to make sure we put the correct coordinates. So in this final segment, the x-coordinate of the center of the pentagon is 60, and the y-coordinate is 40. So that should put it in the correct position. Perfect. You can see the pentagon is in the correct position. Now we just need to worry about the line. So the starting position of the line, let's duplicate and add the line. The starting position of the line does not change. So we're going to take this out as well. Let's determine what this starting position is. It has x-coordinate 60. So let's put that value here. And it has y-coordinate 50. Perfect. So now we actually see that the starting position of the line is correct. We just need to adjust it so that this end point is changing as time goes along. Well, once again, we're going to have to think about the relation between this change and time. So the y-coordinate of the point of the endpoint is not changing, right? It's not moving up or down. So we're going to keep this as 90. We're not going to worry about that. It's just moving to the right. At time equals 80, the x-coordinate equals 40. At time equals 90, the x-coordinate equals 50. Can you see what's happening here? Can you spot the pattern? At time equals 100, the x-coordinate is 60. So actually, the difference between time and the x-coordinate each time is 40. 100 minus 60 gives us 40. 90 minus 50 gives us 40. 80 minus 40 gives us 40. So we're going to do something very similar to this, but we're going to change this to a difference of 40 instead of 20. Let's make sure our pentagon shows and just check from the beginning that everything runs smoothly and the shape moves exactly as we wanted it to. And we can see that it has. Now notice that even though it's running correctly, I didn't get this indicator saying that the answer was correct. What I need to do is run and have it run from the start, go to the very end, and then it shows me this correct banner to tell me that the answer we have just written is correct. So we can now advance on to our next question of the challenge. Return to the nest. The ant, seen on the right side of the maze, is a long way from home. Write a program to help the ant get to the ant's nest, the white square. So we can see the ant here. It is actually quite small, so I'll zoom in a bit. And we need to get it all the way to the white square. So these tabs, most of them we have seen before. So we've got movement, and this allows it, to move in certain directions. We can turn right or left and then keep moving. So let's just see. You can set the speed when you run the program. Let's set it to slow. So it's going to move forward twice, turn right, and then move forward. Now, the thing is, the ant is actually a very long way from home. So if we want the ant to get there and write some code that is efficient, well, it's going to be difficult to just keep writing different blocks to actually get it there. And this is partly because in here it's not always very obvious just how much it's actually going to move by doing one move forward. Let's try. So if we do 2 turn rights at the start to make it turn around and start facing the left, and then it's going to start moving forward. Let's make sure it's very slow. And you can see it's moving in the right direction. But we're going to have to write quite a lot of code and try so many moves and turns to be able to do this. Right, so here we see we hit a wall. And it's not even pausing at that end for us to see where it is exactly. So, I had to do one more move forward before I turned left. So we need a more systematic way to get the ant to the white square. And this is where loops come in. So we've got these loops, which we can say, repeat some code a number of times. So for example, here, instead of doing move forward 3 times, well, I could delete these and I could say repeat 3 times. Let's even make it, let's do this. Let's even make it 10 times and see where that takes us. So it's getting us somewhere, and we can actually use these repeat certain number of times blocks to get us through the maze. But still, that's quite a lot of twists and turns, and it's not very easy to get to the white square. So what we're going to need to do is an even more systematic way. And this is a very, very important algorithm in pathfinding and solving mazes. What we essentially want to do is get the ant to the closest wall in the maze. Then we're going to say, stick to that wall and keep walking along that wall. And we can choose any direction, right? If we choose for it to go up from here and keep sticking to the wall, it's going to stick to this wall. And it's going to turn, keep sticking to the other side of the wall now. It's going to move this way, then to the outer wall. Turn here. And it'll keep going, keep sticking to the wall. Now, it is going to take longer for the ant to get there, but it's not a restriction in the question. There's no restriction on the time needed for the ant. What's actually important is, your time, the programmer's time, because this is a timed challenge. So if we can write more efficient code that eventually does get it to the white square, then we will do that. Well, let's think about how we're going to do this. We're going to start by first having the ant move to the wall. So that's 2 moves forward, and then we can either choose this route that I just showed, but let's try doing it the other way, kind of moving down and sticking along this wall, and you can check that eventually it does actually get the ant all the way to the white square. So it's going to get here and around, wrap around this wall, go up here, go to the corner, turn here, and get to the white square. So we're going to get it to this wall first. Then it's going to turn right. Remember that we're always considering the ant's perspective. If this is forward, then this is right. Moving this way, down from our perspective, is going right for the ant. So we're going to have it turn right and just check that we need 1 more move forward to get it to the wall, and you can see that actually it got to the wall and turned right. Now here we're going to make use of blocks like this. This means it's quite similar to, the if block we saw in the previous question, but this is more specific. The condition that it's checking here has to do with the fact of whether there is a path ahead of it or whether there's a wall. So here we're saying, for example, if I do if path ahead, move forward, what the ant does is it checks, is there a path ahead or is there a wall? If it's an empty space, it's going to move forward. If it's a wall, then it's going to do something else, and this is what I put in here. Well, we're going to use this to do this systematic way of wrapping around the wall. Now, this algorithm we commonly refer to as the left-hand rule, which means the ant, as it's moving along, will always check if it can go to the left. That's always going to be its main priority because the wall is on its left. If it can go to the left, it will. If it can't go to the left, it's going to keep moving forward. So, if it starts over here, it checks, can it go to the left? Well, there's going to be a wall, so it's going to move forward. Can it move to the left? There's a wall, so it moves forward. Can it move to the left? No. Can it move ahead? Well, also no in this case. So what we need to then account for is if it can't move left and it can't move ahead, then it has to move to the right. So let's try this. We're going to say, if there is a path to the left, then what you're going to do is turn left and move forward. So let's see where that takes us. Right, it stops straight away because actually there's no path to the left. So let's say actually if there's no path to the left, move forward. And you can see this time it moves that 1 extra step forward. And we wanted to repeat this decision-making process. We can use a repeat certain number of times, but we don't know how many times it's going to require the ant to make this decision before it gets to the white square. So in the movement tab, there is a repeat do. So every time it's going to repeat everything in here. So it's going to check, is there a path to the left? If there is, turn left and move. If there is not, just move forward. And this makes the ant get to this point. But you see it gets stuck over here because we still haven't added that condition we spoke about, which if there's no path forward, then turn right. And this is where we're going to have to do a neat trick, which is we're going to add another one of these in here. If there is a path to the left, turn left and move forward. Else, so if there's no path to the left, if there is a path ahead, move forward. This is basically like the else if that we did in the previous question. So we could do it by doing the if, and else, but this just makes it easier because it includes checking for paths within the block. So if there is a path to the left, turn left and move forward. If you don't find a path to the left, check if there's a path ahead. If there is, you're going to move forward. Else, so this means if you couldn't find a path to the left and you couldn't find a path ahead, well, what you're going to have to do is turn right and move forward. And let's check what this does. We're going to need to stop the execution and run it again. And you can see this time it actually turned right. Here, it turned left as soon as it could, because that's always the first decision it makes. The priority is always to going to the left. As long as it's sticking to the wall, there is no left. If it hits a wall, there's no path ahead, so it's going to turn right. So here it's just moving ahead. It's doing this, basically. And now it's gotten to this point where it turns right. Now it does turn left twice. And it keeps sticking to the wall. Let's make it a bit faster. And it does exactly what we want it to. It sticks to the wall and gets to the endpoint. Now, the nice thing is, as we said, that we could have done this the other way around. So instead of turning right when we got to the wall, we would have turned left. And since we're going this way, the first priority should be checking if we can move to the right. If not, we move ahead. If neither of those is an option, we go to the left. So we're going to change around some of these. Priority is if there's a path to the right, move to the right. Else, if there's a path ahead, move ahead. Else, so that means there's no path to the right and there's no path ahead, you're going to turn left and check what this does. It moves along the wall from the other side. Now this is exactly the same idea, but we call this the right-hand rule, because it's always prioritizing going to the right. And you can see that even though it might take the ant longer to get there, it took us a much shorter code than if we had done specific instructions for it to actually go through the maze and get to the white square. Perfect. So that brings us to our next question, pruning flowers. Our task is to complete the function provided so that it outputs a text string with any duplicate flowers removed. Remember, your program must work with other inputs or it will be marked incorrect. So, for example, if the input that is given into the program is daisy space ivy space rose space ivy space tulip, what the program should do is find any repeated flower names, so any duplicate flowers. In this case, ivy is actually repeated. We have it here for the first time and here for the second time. And what should happen is our program should get rid of this second repetition and just output each flower once. In many questions, we will get an instruction like this, which is do not alter the blocks provided. So this program has been, or this canvas has been set up in a way where there is a function that does a specific thing, and then to test it, they execute the function with a certain input. What they mean here is that our program should work for any inputs where we give flower names and some of them are repeated, not just daisy, ivy, rose, ivy, tulip. So if we add another rose at the end, the output should be the same. It should remove that repeated rose. Now, it's fine to move these blocks around to kind of make space for what we want to write, but we shouldn't change any of them. Not the input, not their names. We leave all that as it is. Let's discuss what these blocks actually mean first. Here, we are creating a function. This is a block of code that we can run with a certain input, and it gives us a certain output. So it's like a certain machine where you give it some data and it gives out some data. For example, in here, the input is flowers and it returns pruned flowers. Then, to actually use this function, once we have written it, we use this execute block. Execute the function called prune flowers with the input flowers being this. Daisy, ivy, rose, ivy, tulip, and this is our example input. Now here we're going to have to discuss a bit of data types. So when we are programming, the data that is stored in different ways. They said, for example, our output should be a text string. This means our output should be some piece of text. So just like here, this is just a piece of text made up of different words, different letters. Now, the input is also a piece of text, and it's a few words separated by spaces. To deal with this string, with this piece of text, it would be easier to split up these words and look at them individually. What we can do to actually do something like that is we can use a list. A list is just a collection of different items. So, I can create a list with numbers. I can say create a list with the number 0, with the number 50, and with the number 20. Now, when I create the list, I need to actually store it somewhere. I need to create a variable, and this is just a place where we store data. So we give it a name so we remember what it is, and we just can access it later on at different parts of the program. So over here, you can create a variable. So I might name my list numbers, and I say set. I click on here to show the menu. and I say set numbers to create list with 0, 50, 20. So numbers is a collection of 3 different numbers, 0, 50, and 20. In our case, we're actually going to need to create a list with, let's call it a flower list. I've used an underscore between the different words. In block-based programming, you can use spaces, but it's just considered better practice to use underscores. So flower list. And in our case, the flower list should be made up of daisy, ivy, rose, ivy, tulip. So I could, open up the text and do daisy and add ivy, rose. Of course, we can click on the blue cog to add more items into the list if we want to. But this means that I can only deal with this specific collection of flowers. Whereas I want my program to deal with other inputs, or it will be marked incorrect. So this is not how I will be creating my list. I'm going to set flower list to, well, what I need to do is take this piece of text and split up the individual words into separate items in my list. And there's a very nice method of doing that in block-based programming. It's this block in lists. It says make list from text. So let's use that. Make list from text. I need to specify what the text is. So in this case, the text is stored in the input variable flowers, right? That's why when we execute it, we say flowers is daisy, ivy, rose, ivy, tulip. So I'm going to go to my variables. I'm going to search for flowers, and I'm going to use it here. The delimiter is us telling the program what is separating these elements in the text. So if we look over here, what is separating the first word and the second word? Daisy and ivy. By default, they put a comma, but actually in our case, there's no comma separating the two words. What separates them is a single space. So in here, I'm going to delete the comma and I'm going to type a single space. Make sure you do that. So I'm going to do a backspace just to show you. This is what an empty text is. A single space looks like this. So we're saying we're creating a flower list from this text by splitting up the words using the spaces in between. So that means daisy is going to be a separate element, then ivy is going to be a separate element, then rose, then ivy again, and then tulip. Now, what I need to do is go through this list and check which of these are actually repeated. Now, one way to then kind of check or store those that are not repeated, or rather a single occurrence of each one, is to create a new list. Call it pruned list. So this is what our flowers will look like as a list after we have removed the repetitions. So I'm going to set the pruned list. Well, we're going to start it off as an empty list. So just to go over it again, we have a flower list, which is made up of 5 items if we use this input: daisy, ivy, rose, ivy, tulip. Then we have a pruned list, which starts off as empty, and then as we go along, we want to enter all the flowers without repeating any of them. So in the loops tab, we're going to see something that we haven't actually seen before, which is this loop. So this one was repeating a certain number of times. This is for repeating while some certain condition is true. This one repeats for each item in a list. So if I do something in here, it's going to be repeated 5 times because I have 5 elements in my list. So the first time this loop runs, I is going to be the first element of the list. Let's first make sure that we are using the correct list, which is flower list. So the first time it runs, I is going to be daisy. The second time it runs, I is going to be ivy. Third time is going to be rose. Fourth is ivy. And the last time it runs, it's going to be tulip. And basically what we want to check is when we are adding these flowers from the flower list into our pruned list, we need to make sure that we're adding them for the first time, because we don't want repetition in the pruned list. So to do this, we're going to use one of the list functions that says, in a given list, find the first occurrence of an item. So in here, we're searching in the list pruned list, and we want to find the first occurrence of each flower that we're looping through. So we're going to put I. This means in the list pruned list, find the first occurrence of that item. So for example, if it's starting off with daisy, it says find the first occurrence of daisy in the pruned list. But the pruned list starts off as empty. So actually, it doesn't find the first occurrence, which means this will give me a value of 0. Because usually it would give me the value, or what we call the index, of the item in the list, which is its position. So for example, if I use the flower list and I say find the first occurrence of, let's do daisy. I'm saying in the flower list, find the first occurrence of the item daisy. So it goes through this list and it finds daisy, the first occurrence of daisy, as the first element in the list. So this will give a value of 1. If I tell it to find the first occurrence of ivy in the list, this will give a value of 2. Rose will be 3. If I say ivy again, well, it's always going to be 2 because I'm telling it to find the first occurrence, and so on. But if I tell it, for example, to find the first occurrence of jasmine, which is a type of flower, but it's not in our flower list, this is going to give a value 0 because jasmine is not in the list. So just to go back to what we want to do, we're saying in the list of pruned flowers, find the first occurrence of that flower from our flower list. Now, if it's not already in the pruned list, then add it. We want it there. So if this equals 0, as in it's not in the pruned list, let's add it to the pruned list. Well, how do we check if this is 0? Let's listen back to what I said. If this is 0, if we go to logic and we find the if statement. If this is equal to 0, so we're going to use this block to say if the first occurrence of that flower in the pruned list is 0, let's make sure it goes in the right place, then add it to the pruned list. And we do that by going to lists and we say in the list, and in this case we're using the pruned list, we're going to insert. We always want to add this as the last element, right? Because, for example, if we check daisy, we want to add daisy at the end, then ivy. I don't want ivy to go before daisy in my pruned list. I want to add it after, so I'm going to add it at the end. So in list, pruned list, insert at the very end, at the last position, this flower I that I couldn't find in the pruned list. So I'm going to go to my variables, find I, and add it to the list. So let's just do a quick summary of what's happened so far. We created a flower list by taking this text and then splitting up any two things that were separated by a space. So that means we got 5 different elements, 5 different words: daisy, ivy, rose, ivy, and tulip. Then we created an empty list, which we called pruned list. And we said, go through the flower list, and for each element, check if it's in the pruned list. If it's not, then add it. If it is, well, we're not going to do anything because we didn't add an else statement, and we don't need one here. So let's just think about what exactly is going to happen. It's going to go to daisy as the first element in the flower list. It's going to check, is daisy in the pruned list? So it does. In list, pruned list, find the first occurrence of daisy. Since it's an empty list, then it's not going to find daisy, and it is going to be equal to 0. So it's going to add daisy to the pruned list. So now the flower list has daisy, ivy, rose, ivy, tulip, and the pruned list has daisy. Then this repeats again, right? That's what we used this for loop for. It repeats again, but this time I is the second element in the flower list. It's ivy. and it checks the same thing. Is Ivy in the pruned list? Well, no, the pruned list only has Daisy at this point. So if it hasn't found it, then add it. So now the pruned list has Daisy and Ivy. And then it goes back and goes to the next item in the list, Rose. Is Rose in the pruned list? No, it's not. It's only Daisy and Ivy in the pruned list. Well, then add Rose to the pruned list. So it does that. Now it gets to Ivy. It checks, is Ivy in the pruned list? This time it is. So let's check actually what's happening here. In list pruned list, find the first occurrence of Ivy. Remember, this time I is Ivy. So it goes here and it finds the first occurrence of Ivy, and that's at position 2 in the list. So the first occurrence of Ivy is 2. It checks, is 2 equal to 0? Well, it's not. So this condition is false. So it does not do this. It does not add Ivy to the end of the list because it's already there and we don't want repetitions. And so it goes back and repeats for the last element, which is tulip. Is tulip in the pruned list? It's not, so add it, and this is what we get. But the issue is this currently pruned list is a list. But when we output, we need to output a text string with any duplicate flowers removed. So we don't want to output a list, we want to output a string. So we kind of want to do the opposite of this. Instead of taking a list, taking a text and making it a list, we want to do the opposite. I want to create a text from the list. And in fact, this same function, if we go to lists and we find it over here, you can swap the order around. I can make a text from a list. The text that I want to create is from the list pruned list. That's the one with no repetition. So I'm going to go to variables, find pruned list. When I create the text, I want the words to be separated by a space. So again, I'm going to change my delimiter to a single space. Now, when it returns, so when this function gives the output, it gives it as pruned flowers. That's the variable they want us to use. So I go to my variables and I say set, make sure this is outside the loop because we don't want this to repeat every time. We want this to happen at the end after we've gone through every single element and checked if it's repeated and added it to the pruned list. So I'm going to set pruned flowers to this text, which is made up from the list pruned list, and separate the words with a space, and then that gives me this output. So I run my program, and hopefully we haven't made any errors. Daisy, Ivy, Rose, Tulip, no repetitions, and it says my answer is correct. So that brings us to the end, or rather the last question from the 4-mark questions. Too short. We're going to hide our menu first and then read the question. Children are only allowed on a fairground ride if they are at least 1.2 meters tall. 4 children queue for the ride and their heights are measured. Our task is to complete the function provided that takes as inputs the heights of 4 children in the queue your function should output how many of the 4 children are allowed to go on the ride. Just like the last question, the program must work with other inputs or it will be marked incorrect. So the input they give here is just one example, and they test with other inputs to make sure that the program works correctly. So what our program should do is check these 4 inputs. If they are at least 1.2 meters tall, they're allowed. And what we need to do is count how many are allowed to go on the fairground ride. 1.41 is more than 1.2. 1.2 is exactly 1.2, and they said at least. So this should be allowed. 1.19 is actually less than 1.2 meters, so this will not be allowed. And 1.21 is more than 1.2 meters. So actually, we have 3 children who will be allowed on the fairground ride. So the output should be 3. Now, once again, they have provided a function or the skeleton for a function, and then we're going to fill the content in. And they have added an execute block which runs the function with these 4 inputs: child 1, child 2, child 3, and child 4. So what we need to do is check how many of these are allowed to go on the ride. Well, at the start of the program, we're going to need to keep track of this in the variable number of passengers. At the start of the program, before we check the numbers, we're going to say that so far we have 0 passengers. And then, as we check each one, we decide whether we increase this number or keep it the same. Now, I'm going to show you 2 ways to approach this problem. One is the conceptually simpler method. The second involves the use of lists, and it's just a neater program to write. Let's start with the first. I set the number of passengers to 0. Then I need to check them one by one to see whether they are allowed on the ride or not. So if they are at least 1.2 meters, I increase this count by 1. Again, when I say if they are more, I'm going to need to do this, right? Because I need the if. So if, let's start with child 1. So I'm going to go to variables, find child 1. Is at least 1.2. So I'm going to need greater than or equal to sign. Remember, this is in the logic. It's in here, and you can change this symbol to greater than or equal to. It's important that we choose greater than or equal to, not greater than, because they said at least 1.2, so 1.2 is actually allowed. So if child 1 is greater than or equal to, numbers are in maths, 1.2, then we're going to need to increase the number of passengers. And you can do this by going to variables. Just like we have a set variable to something, we have change variable by something. And this is what we're going to do. We're going to change number of passengers by 1. This means increase it by 1. So if the first one is allowed, increase the number of passengers from 0 to 1. And what I can do is I can just copy this for the second child, and then copy it for the third child. And as I said, we are actually allowed to move these blocks, but we are not allowed to alter them. So I've just moved it down to make some space because we still need to check the fourth child to check if they are at least 1.2 meters. Then we change the number of passengers by 1. And then in the end, we return the number of passengers. And if you run that, it does work. It gives us an output of 3. 3 of them are allowed to go on the ride, and that gives us a correct answer. Now, what we could have done is instead of doing the same thing 4 times, we could have created a list. So let's create a variable called a child list. And we're going to set that to include all 4 children. So let's do that. I have child 1, child 2, child 3, but I still need that space for child 4. Remember, I can press on this blue button, add another item to be included in the list, and add child 4 to the list. So what I've done is set the number of passengers to 0, then I've created a list with these 4 children included, and now I can do something similar to what we did before. For each element I in the list, child list, so I'm looping through the list going one by one. And I can do this. If I, because remember this takes all the different values in the list one by one, if I is greater than or equal to 1.2, change the number of passengers by 1. So instead of having to do this if 4 times, you write it once and you let the loop execute it 4 times, once for each I in the child list, for each of these child 1, child 2, child 3, and child 4. If we run that, we also get 3, which is the correct answer. All right. Now we're on to the slightly more advanced questions, where each is worth double the number of marks as the first 8. So I have rolling ball. Let's hide the menu. Now the first thing it says is press run below to see how a line is used to make a horizontally moving circle appear to roll. So let's see what they're talking about. So they're referring to this circle. We've seen something similar with the pentagon moving from left to right. But adding this stick in the middle makes it look like the ball is rolling. It's not just moving left to right, but there is a rolling movement. So that's the purpose of adding that orange stick in the middle of the ball. Your friend Hannah, a maths genius, has been helping you make this. She has simplified things by providing some complicated maths in 2 variables, a and b. So she set a to 10 times the sine of negative 18 divided by pi times the time. And same thing for b, but instead of sine, it's cosine. And Hannah says you don't need to worry about what these do if you just follow my equations below. Hannah has not used Blockly before, and so has left you to finish. So Hannah has done the maths side of it, and we're going to do the programming side of the project. We will of course remember to read the information. For more programming space, use the hide menu. This we already know, we've already done that. Code for two variables a and b is provided. That's written above, and it's already included in the canvas here. So we don't even need to put down these blocks and set the amounts, it's already included. The colors shown are a faded version of the true colors. So just like we saw before with the pentagon on the line, these are just the faded colors, and when we actually put the shapes, we will see the colors more intensely. The circle is purple, middle right in the color picker. The line that forms the stripe is orange, which is top middle of the color picker. All new variable values are multiples of 10, except the line thickness, which is 1. Again, this is a very important piece of information. So are the colors, of course. But here we will know what values to put into the shapes when we create them. Then we have Hannah's equations for the stripe. So we'll get to those in a minute, but let's start with the circle itself. Other than A and B from Hannah's equations, they've also included the grass, so we don't need to do that, it's already included. It's actually a line that starts at 0, 85, ends at 185, and it has a thickness of 30. So it's a very thick line, and it seems like it's a grass ground. Now, we need to add the circle. Remember, that's in shape. So I'm going to add the shape. We can attach those, that's absolutely fine. And I'm going to call it the ball. Remember, for it to be a circle, we choose the number of sides as 10. This is how we draw a circle with this block of code in the coding challenge. The color of the circle is purple, which is middle right in the color picker. So it's this one over here. I need to choose its position and radius. Now, the radius of a circle is the distance from its center to its circumference. So from here to here. It's going from 60 all the way to 50. So it has a radius of 10. Now, if you didn't know that, you can still arrive at this result, because they said all new variable values are multiples of 10. So the radius must be a multiple of 10. Well, currently it's 20 and it's too big. What multiple of 10 is less than 20? Well, 10. And now it's the right size, but it's not in the correct place. Let's think about its starting position. The x-coordinate is 0, so let's put that for now. The y-coordinate is 60. Remember, the x-coordinate is the one that goes from left to right. The y-coordinate is the one that goes from top to bottom. So now it's in the correct starting position, but what we want it to do is actually move along as the time goes by. Well, let's think about it as we did with the previous ones. How are the x and y coordinates changing with time? Well, the y coordinate isn't changing because the ball is not moving up or down. It's just moving to the right. So we're going to keep the y coordinate at 60. Let's think about the x coordinate. When time is 0, the x-coordinate is 0. When time is, let's keep it at 20, the x-coordinate is 20. When time is 50, the x-coordinate is 50. And when time is 100, the x-coordinate is 100. Remember, we're always looking at the center of the circle. So it seems like the x-coordinate is exactly equal to the time value. We access the time value from the movie tab and we check. And now, actually, we can see that the circle is moving in the right way. We just need to add that orange stripe to give it that rolling effect, because otherwise it's just a circle moving without that orange stripe. It's just a circle moving right to left. So what we're going to need to add is a line. So they said here, the line that forms the stripe is orange. So we're going to add a line. Let's scroll down. Let's call it stripe. That's what they called it in the question. It's orange. Let's just check what the position of that is in the color picker. That's top middle. So it's this one here. The line thickness is 1. So that's already correct. And now we just need to input the start and end position of the line, because currently it's just going from 0, 0 to 20, 20. Well, to determine the start and end position, we're going to have to use Hannah's equations. Hannah says the start position x, so the x-coordinate of the start position, is the x value of the center of the circle plus a. So we're going to need a maths block here. We're adding two things. One of them is the variable a, which Hannah has already defined. We don't need to worry about what it is. So we're adding the x value of the center of the circle. Let's go to the circle. What is the x value? The x value of the center of the circle is time. Remember, we said the x position of the center of the circle moves exactly with time. When time is 0, the center of the circle is at x0. When time is 100, the x-coordinate of the center of the circle is 100. So x value of the center of the circle is time. Let's duplicate that and add it here. And that's going to be the start position x of the stripe. So that's 1 out of the 4 done. Let's see what this looks like. So we can see some changes, but we need to, of course, alter the rest. The start position y is the y value of the center of the circle plus b. So again, we're going to need to add two things. So we're going to go to the Maths tab, choose the addition. We're going to choose the variable b to add. And we need the y value of the center of the circle. Well, what's the y value of the center of the circle? That's just 60. So we're going to go to Maths and add 60. So 60 plus b. That is the start position y according to Hannah's equations. Then I have the end position x, which is this one over here. This is going to be the x value of the center of the circle minus a. Now, if you notice, it's exactly the same as this, except here we're adding a, whereas here we're subtracting a. So what we can do is pick this up, duplicate it, and just change the plus to a minus. And that's going to be our end position x. The end position y is y value of the center of the circle minus b. So once again, it's the same as the starting y coordinate, but we're subtracting instead of adding. So I'm also going to do the same thing. I'm going to duplicate this, and I'm going to subtract instead of add. Let's enable this block, and let's check that this is working. So something has gone wrong here. Can we identify the error? The error, of course, is here. We've just duplicated, but we didn't change this to a minus. So the first two are additions. The last two are subtractions. And now if we try that, you can see that the orange stripe is moving as we want it to create this rolling effect on the ball. And we always run our program to check whether this is the full solution, and it is in fact the correct solution. So that then brings us on to our last question of this set from the coding challenge. Longest palindrome. A palindrome is a word that reads the same backwards and forwards. For example, radar. Okay, if you read it forward, it's R-A-D-A-R. If you read it backwards, it's R-A-D-A-R, radar. Complete the supplied function so that it outputs the longest palindromic word in the supplied sentence. So for example, if we give it this sentence, the race car sat level on the track. What the program should do is go through each word. First of all, it should assess, is this word a palindrome? And then, if it is it the longest palindrome? Well, in this sentence, there are actually two palindromes. Race car, R-A-C-E-C-A-R. Backwards, R-A-C-E-C-A-R. Race car, forwards and backwards. The second is level, L-E-V-E-L. Backwards, it's L-E-V-E-L, level. But race car is made up of 7 letters, whereas level is made up of 5 letters. So actually the length of the word race car is greater than the length of the palindrome level. So when we're looking at the longest palindrome, the output should be race car. And that's what we should get. Some constraints. Test input provided will only include letters. There will be no punctuation or other character symbols. Notice that the sentence, for example, has no full stop at the end. In fact, it doesn't have any punctuation, any characters. The only input we're going to get is letters. And there will always be only one longest palindrome. That means they would not, for example, give us another palindrome in the sentence that has 7 letters. There is only one with this longest palindrome, one with the greatest length. As before, they've provided some skeleton code that we're not going to change, but we're just going to move this down to make some space for our work. So we have this function, find longest palindrome, and it's going to return the longest palindrome. In this example input, that's going to be race car, and then we execute the function here with the example input. Now, looking at a sentence and going through every word to check something is actually something that we've already done just before in one of the questions. So try and remember, how did we take a sentence, break it up into words, and then check each word on its own? Try and remember. Well, let's create a variable for this first of all. Let's call it words. So I want to set words to be these individual words stored as separate elements. Well, what we did was we went into lists last time and we used this function that allowed us to create a list from a piece of text. So it took something like the race car sat level on the track, and then it broke it up into individual elements. And it did that. Well, first, the text that we need is sentence. So we're going to go to our variables, find sentence, and put it in here. And we put the delimiter, which is what is separating these words in the sentence. Well, it's just a single space. And now words is going to be a list made up of the, then race car, then sat, level, on, the, and track, all as separate elements in the list. Now, it's common practice in programming, and we've seen it in previous questions, where, for example, if we're counting something, we say at the beginning of the program, the count is 0. And then as I go along in the program, I'm going to increase that count by 1. We're going to do something similar here, which is at the very beginning of the program, we're going to say that the longest palindrome, this thing that we should be returning at the end, is actually just an empty string. So this empty string is the longest palindrome we have. And then every time we get a new palindrome, we're going to compare it to this one and check, does it have a greater length? Is it longer than the existing one? If it is, then let's make this new thing our longest palindrome. So what we want to do is we want to actually go through each word. How did we do that last time? Well, we had a specific loop that goes through a list. So for each item, which we're calling I, in the list words, so I'm going to go to variables, find words. For each item I in the list words, I need to check, first of all, if it's longer than my longest palindrome, and then check if it is actually a palindrome. Well, I need to check two things, and both I said if it has a greater length and if it is a palindrome. So that means I'm going to use an if statement. Now, since we're checking two different conditions, and I need both of them to be true, I can do this in two separate ways. I can say if the length, so let's check. We want it to be length of this word is greater than the length of the longest palindrome. So we need the greater than sign. That was in logic. And we're going to choose the greater than sign. The length of a text is going to be in text. So we can find it here. You choose length of, and then you put the text you want. Now we don't want to write out any text. We want to use a variable because we're comparing the length of I with the length of the longest palindrome. So the first thing we're checking is if the length of this word is longer than the length of the longest palindrome. Because if it's not even longer, why should we check if it is a palindrome? It doesn't matter if it's a palindrome or not. It's not longer than the longest palindrome. So there's no point checking. So we want to check if two things are true. This and something else. So we want to check if the length of I is greater than the length of the longest palindrome, and we want to check if it is actually a palindrome. To do this, it's going to be too complicated to do this in here or even inside this function. So what we're going to do for this question is we're going to create our own function. So far, we've used only functions that they've kind of given us the skeleton for. For this question, let's create our own function. We're going to go to the Functions tab, and we choose which one we want to do. This is for running a function. So just like here, for example, it's doing find longest palindrome. It's executing it. We don't want to run it yet. We want to create the function. And we want it to return a value. So we want a function to say, let's call it check palindrome. So it takes a word and it returns whether this word is a palindrome or not. Well, to add an input to the function, like here, the input is sentence, what do? Of course, if we want to change any block, and it has a blue wheel, we're going to go there and check. And in fact, this is where you add inputs. So we want an input name. Let's check the palindrome of a word. That's going to be my input. Now, we'll get to this in a second. But essentially now I've created kind of the skeleton code for it. And here I can say, if the length of I is greater than the length of the longest palindrome, and I can now, run the function with the word, in this case, my word is I. Well, the way I'm going to write out the function is it will return true or false. So in the logic tab, we actually have true and false values. So it'll return true if the word is a palindrome and false if it's not. So here, I'm going to be checking if we check the palindrome with the word I, and that turns out to be true, well, that means the word is a palindrome, and I'm going to need to set this to the longest palindrome. Let's just summarize where we're up to so far, because we've done quite a few things actually. We have our main function, which is to find the longest palindrome. The first thing we did was we created a list called words from the text that we got as input. This is something we've done before. We take the text, we split it up into individual words and store those as elements in a list. Then I start off by saying the longest palindrome is just the empty string, the empty piece of text. Then I go through each word in this list. So first I is going to be the, then I is going to be race car, then I is going to be sat, and so on. Every time it's going to check two things, and both of them must be true. It's going to check if the word I is longer than what I've currently stored as my longest palindrome, and it's going to check whether the word is actually a palindrome. And we're going to do this here in a separate function to just make our code look neater. Separate different functions, different things that we want to do into different blocks of code. So if this word from the list is actually longer than the longest palindrome, and it is a palindrome, well then that should be my longest palindrome. So I'm going to set the longest palindrome to be this word I. Again, the only way I can get to this block of code is if both this and this are true. If the word is longer than my current longest palindrome, and if it is actually a palindrome. That's why it's longest palindrome, right? It needs two things for it to be the longest palindrome. It needs to be the longest of the palindromes, and it needs to be a palindrome. Right, so we're pretty much done with this part, but now we need to think about how we check whether a given word is a palindrome. Well, let's think about it. If I'm looking at a word like race car, essentially, if you kind of think of the E as a mirror, then it should reflect the first half of the word exactly into the second half. Meaning, the first letter is the same as the last letter. The second letter is the same as the second to last. The third is the same as the third from the last. The fourth is the same as the fourth from the last. And then it needs to stop there. Because there's no point checking, going the other way whether C is the same as C, because we've already done that. So when we're doing this, we're basically checking two things. We're checking from the left and from the right whether two things are the same. So let's create variables to indicate kind of the left and right position that we're checking. So we need two variables. We need a left position and a right position. Well, when we start checking, the left position should be the first letter. So we're going to set it to 1. The right position is going to be the last letter. Well, how do we know what the index, what the position of the last letter is? Because, for example, if I'm looking at sat, the last letter is the third letter. If I'm looking at level, the last letter is the fifth letter. If I'm looking at on, the last letter is the second letter. So actually the last letter depends on the length of the word. In race car, the last R is the seventh letter. It's the last, and the word has 7 letters. So actually the right position is just going to be equal to the length of the word. In sat, because it's a 3-letter word, the last letter is the third letter. So we're going to use length of again, and this is going to be the length of the word. This is the input to our check palindrome function. And we said we're going to keep track of whether it's a palindrome or not by, returning true or false. Well, one way to do this is, before checking the letters, assume it is a palindrome. So let's say it is. So it's true. And then we check the first letter with the last letter. Are they equal? Cool, that's fine. We carry on. As soon as we find a pair that don't match, so in race car, we won't do that. But in other words, as soon as we find a pair that don't match, for example, in sat, if I check the first and the last letter, S is not equal to T. It's a different letter. So I'm going to change it to false. No, it's not a palindrome. As soon as I find a pair that's where the letters are not the same, I'm going to say, no, it's not a palindrome. Otherwise, I'm just going to keep checking until either I get to a point where these indicators, these positions that I am using, meet up, just like here, we said at letter E, they coincide. The position, the indicator that was coming from the right and the one that was coming from the left collide here, and that should stop because there's no point checking in the other direction. So I'm going to create a variable called is palindrome. And as we said, we're kind of giving it the benefit of the doubt at first. We're saying at the very beginning, let's assume it is a palindrome. And only when we find a pair of letters that don't match up do we change this to false. So we set is palindrome to true. Now, what we're going to need to do is write some kind of loop that, keeps moving the left position to the right, one letter at a time, and the right position to the left, one letter at a time, and checks the pairs. So let's think about what's going to happen inside the loop first. We're checking if I'm checking if two things are equal, two letters are the same. Well, how do I use the position of a letter, this index, to find the specific letter in the text? Let's check the text tab. You see here, we have this block that says in a given text, get letter number something. So I want to check if in the text word, oh no, sorry, we picked the wrong block. We want this one. If in the text word, letter number, well, the letter at the left position is equal to that at, let's put this here for now, is equal to that at the right position, that means they match up. So actually, it's quite good at this point. But what we want to do, remember, we said we're going to check this with this. We're going to check this with this. What we're trying to find is not a matchup. We want to find a pair that doesn't match up so that we can change this to false. So actually, if I find a letter on the left position that's not equal to a letter at the right position, then I'm going to set is palindrome to false. Let's just make some space for this, because I still don't want to add it, because this is going to be repeated. Because every time I check, as I said, I'm going to need to move my left position to the right and change my right position to the left. So that means I'm going to change my left position by 1, and I'm going to change my right position. Try and think about it. If it's going to the left, if it's starting with the length of the letter, so starting at 7 here, I want it to move to 6. What am I doing? Well, I'm changing it by -1. I'm moving it to the left. And I want to keep repeating this until the right position and the left position collide, or until they meet. So here we're going to use a loop that we haven't used in any of the questions we saw before. It's a while loop. A while loop repeats while some condition is true. So in this case, I want this to keep repeating as long as the right position and the left position have still not met. So while the right position, or let's do, while the left position is still less than or equal to the right position. And this is going to go in my function. And in the end, what I return is this variable, which holds either true if the word turns out to be a palindrome, or false if it turns out that it's not. Now, let's just do a quick summary of this function, because we did quite a lot of things. And I'm going to use 2 words as examples. I'm going to use race car and track. So let's say we get to this point in this function. It's going through each word and it gets to race car. So I is race car, and it's checking here if length of I is greater than the length of longest palindrome, and check palindrome I is true. So now it's calling this function. So the word given as input to the function is race car. Left position is 1, right position is length of word. Word is race car, so its length is 7. So left position is 1, right position is 7. And we're saying, as far as we know for now, it is a palindrome. Now, it keeps repeating while left position is less than or equal to right position. Currently, left position is 1, right position is 7. It checks 1 less than or equal to 7. That's true. So it's going to run what's inside the loop. If the letter number 1 in this word is not equal to letter number 7, then this is not a palindrome. Letter number 1 and letter number 7. Actually, they're equal. So we're not going to change this. It's not going to get to this point. What's going to happen is we're going to increase the left position by 1 and decrease the right position by 1. So now left position is 2, right position is 6. And it checks. Is left position less than or equal to right position? Is 2 less than or equal to 6? Yes, it is. So it's going to run what's inside the function. If the second letter is not equal to the sixth letter, is palindrome is false. Well, the second letter is equal to the sixth letter. So it's not going to change this to false, but it's going to move the left position by 1, right position by -1. So now 3 and 5. It checks here first to know if it's going to run the loop. Is 3 less than or equal to 5? Yes, it is. So it's going to run the loop. If the third letter is not equal to the fifth letter, change is palindrome to false. Well, the third letter is equal to the fifth letter. They're both C. So actually, it's not going to do this. It's going to change the left position by 1 and the right position by -1. So now the left position is 4 and the right position is 4. It checks here. Is left position less than or equal to right position? Is 4 less than or equal to 4? But it's equal, so this is going to be true. It checks if the fourth letter is not equal to the fourth letter. I mean, they're exactly the same letter, so they have to be equal. It's not going to change this to false. Now it changes the left position by 1, the right position by -1. And so the left position is now 5, and the right position is 3. Is 3 less than, no, left position is 5, right position is 3. Is 5 less than or equal to 3? Well, no, it's not. So this condition is false, so it stops running the loop and it returns is palindrome, which, since we never actually got to this block, is true because we set it to true in the beginning. So it basically tells us here that race car is a palindrome. Now, if we do the same thing with the word track, it does the same. So it says left position is 1, right position is the length of the word. So right position is 1, 2, 3, 4, 5. And it repeats, while left position is less than or equal to right position. Is 1 less than or equal to 5? Yes, it is. So it's going to run the loop. If the first letter is not equal to the fifth letter, is palindrome should be changed to false. The first letter is a T, the fifth letter is a K. So actually, this is true. They are not equal. So it changes is palindrome to false. And it keeps checking other pairs, but because we've changed to false and there's nothing after it that could possibly change it to a true value, then when it returns is palindrome, here it's going to return false. And in this case, this part is going to be false. So we don't get to this block. And so track isn't even considered to be longest palindrome because it's not even a palindrome. And if we try that, we get race car is the longest palindrome in this example input. Cool. So we have done all the questions. You have seen that actually the first few are somewhat simpler than the last two, and that's why they count towards only half the marks. So make sure you use your time correctly as you go through these questions. Remember, always read the information. Sometimes it's just a nice reminder to hide the menu to give you more space. Sometimes it does include quite a lot of important information, such as with, where did we see it? Here, for example, it gave us information about the faded versions, the colors of the shapes, and the thickness and the measurements that we're going to need in our shapes. So do make sure you check this information. Remember, for the questions like this, when they give us some code, we shouldn't alter it. Leave it as it is. You can move it around to create more space for you to write code or to add blocks, but do not change any of the measurements, do not change any of it, except if they told you in the question, like they did in Hilbert Hiccup, that one of the numbers is wrong. So there's a single numerical error, and that's what we had to do. We had to find this numerical error and change it. Perfect. I hope you found this useful, and I wish you the best of luck with completing the UK Bebras Coding Challenge. Thank you.